In this next lesson, we're going to talk about adding and subtracting fractions. This lesson is going to be pretty straightforward, pretty simple. It just kind of builds on what we talked about last lesson. So let's go ahead and start with talking about adding and subtracting fractions. You've seen this slide before. As long as two fractions have the same denominator, all you have to do is add or subtract the numerator. The denominator does not change. So let's go ahead and take a look at two addition problems, or an addition problem and a subtraction problem rather. The first one's an addition problem. So we see that our 6 in our denominator is the same. So that 6 carries over to our answer, or our sum in this case. And then all we have to do is add our numerators. So we're going to add 2 plus 3 and we get 5. And that's the sum of these two fractions. Now our next problem is a little bit trickier because we're taking a whole of 1 and we're subtracting 4/9, and we need to understand what that whole represents. So what we need to do is we need to look at the other fraction for some assistance. We're taking 4/9 away. Well, what would a whole be equal to if we can take 4/9 away from it? The denominator in our fraction indicates how many pieces are in the whole. In this case, our denominator tells us that there are 9 equal pieces that make up our whole. Now, if we have a whole pizza and it has 9 slices, well, there are 9 slices in our pizza. So that fraction as a whole would be 9/9. When we see the same numerator and denominator, it's equivalent to 1 whole. So we have to take this 1 whole and we have to change it to represent the fraction that we're looking for before we subtract. Because remember, we can't subtract fractions unless they have the same denominator. And 1 whole doesn't even show us a denominator. So we need to turn that into a fraction. So we're going to take our 1 whole and we're going to change it to 9/9, which again represents our 1 whole. And this is important, and this concept is going to come up over and over and over again the next few chapters. The numerator and denominator, when they're the same, they represent 1 whole, and we look at that denominator of the neighboring fraction to help us indicate what that whole is going to look like. Now we can subtract. 9/9 minus 4/9 gives us 5/9. So once we figure out that whole thing, then we're able to go ahead and subtract fairly easily. I want you to go ahead and solve these problems. You have 6 problems to solve. We're going to add or we're going to subtract, so make sure you're looking at the sign. For this first problem, we see our denominator is the same, so we go ahead and bring that denominator over, and then this is an addition problem, so we're going to add 1 plus 3 gives us 4, and that's it. Number 2, we're looking at the same thing. Our denominator is the same, so we bring that over, and this equals 7/7, and 7/7 can be rewritten as our 1 whole. So 7/7 is equal to or equivalent to 1 whole. Our next problem is a subtraction problem. So we're going to go ahead and subtract 8/9 minus 4/9, and our 9 comes all the way over. 8 minus 4 gives us 4. Our next problem is also a subtraction problem. So we're going to go ahead and bring our 15 over as our denominator. Then we subtract 7 minus 3, and we get 4/15. Our next problem is an addition problem. So we're going to go ahead and add 3 plus 9 and we get 12, and then our 15 comes over. And then for a problem like this, as well as for number 1, we can always simplify these fractions as well. So in order to simplify 4/6, we would divide by 2, and this would give me 2/3, and that would be 4/6 in simplest form. We could also do that for 12/15. They both have the number 3 in common, so I could divide by 3, and this would give me 4/5 as my simplified fraction. Now I want you to pay close attention to question number 6. What would 1 whole be equal to in this case? Because we're subtracting 1 whole minus 2/5. Our denominator is going to help us with that. It shows a 5 in the denominator, which means 1 whole is going to have 5 equal pieces. So we can cross out this 1 whole and we can change it to 5/5. 5/5 is going to be equivalent to 1 whole. And now we can subtract, because remember, we want our denominators to be the same before we subtract. So 5/5 minus 2/5 gives me 3/5, and that's in simplest form already. All right, we have some word problems to go ahead and look at. Our first word problem says Tatum ate 5/8 of her pizza. Emily ate 3/8 of her pizza. How much more of the pizza did Tatum eat? Go ahead and solve this problem. I see in my problem that I have how much more of the pizza did Tatum eat, so I'm going to be subtracting. So go ahead and subtract 5/8 minus 3/8. And when you do that, you're left with 2/8. So in order to answer this question, Tatum eats 2/8 more of the pizza. Alrighty. Let's look at our next question. Tadarius had 1 cup of cereal. He ate 4/6 cup for breakfast. How much cereal does Tadarius have left? What equation are you going to set up for this problem, and then how are you going to solve it? For this problem, we have our 1 whole cup, and we're subtracting 4/6 because he's eating that, and we want to know how much do we have left, so we have to do some subtraction. In order to subtract, though, we first have to change our 1 whole into a fraction. So what fraction is 1 whole equivalent to in this problem? In this problem, our 1 whole, we look at our denominator of our neighboring fraction, and it's a 6, which means that there are going to be 6 pieces in our whole. And now we can subtract. 6 minus 4 gives me 2, and then my denominator of 6. And then this fraction can be simplified. All we have to do to simplify this fraction is we have to divide by 2 because both of our numbers are even. So we'd be left with 1/3. So Tadarius has 1/3 of his cereal left. Let's take a look at one final question. Lexi says that 1/4 plus 1/8 is equal to 2/8. Mia says that 1/4 plus 1/8 is equal to 3/8. Whose answer makes sense? Explain. Go ahead and solve this problem. What do you think? Which of these answers makes the most sense and why? If we were to look at this problem, remember we talked about the denominators having to be the same before we could add. Well, notice how our denominators are different. We have a 4 and we have an 8. And we can't add until our denominators are the same. So what can we do to make our denominators the same? We can find a common denominator and then change our fractions to have that common denominator. Now our answers kind of point to what our common denominator would be. Our common denominator would be 8. So let's go ahead and let's change our 1/4 to have an 8 in the denominator. So we need to set up one of those equivalent fractions. And if we set up our equivalent fraction, 1/4 is equal to something over 8, I'd have to multiply my numerator and my denominator times 2. And when I do that, I get 2/8. And now I can replace this in our problem. So 1/4 is equivalent to 2/8. So my problem would now be 2/8 plus 1/8. And what is that equal to? That's equal to 3/8. So who is correct after all? Mia is correct because Mia said that 1/4 plus 1/8 was equal to 3/8. All right, that's all for our lesson. The important takeaways are when we're adding fractions, they must have the same denominator before we add them. And if they do, all we do is add that numerator. When we're subtracting fractions, if we have a whole, we need to identify what that whole is based off of the neighboring fraction. Look at that denominator and that'll tell you how many equal parts are in your whole. And then you can subtract. And when we're reading our word problems, make sure we read them clearly so we know if we're adding or subtracting. That's all for our lesson. See you tomorrow.